to 0 when t is less than equal to 0. ft is equal to 1 when t is greater than 0. So if you want to take the Laplace transform of this function, this will be equal to fs. So this is 1 by s. So if your function is unit step, so Laplace transform of ft, that is equal to this. Okay. Next, number 2, exponential function. So if ft is equal to e to the power minus alpha t, Laplace transform of ft, this is equal to 1 by what? 1 by Laplace transform of e to the power minus alpha t.
1 by e to the power minus alpha t.
This is the Laplace transform. Okay. Then sinusoidal function. Sinusoidal function. Okay. So in this case, ft, say, is equal to sine of omega t, right? So this is equal to twice j e to the power j omega t minus j omega t. So Laplace transform of this is equal to is equal to 0 to alpha 2j e to the power j omega t minus e to the power minus j omega t e to the power minus s t dt. So this is directly, you can write in your problem, in your this deduction, you can directly write this expression. No need to go for this. This is the mathematical part actually. So Laplace transform of sine omega t is always this. You can directly write this expression. This is the final expression. So no need to show everything is in intermediate step. This is the mathematical part. So similarly, we can write Laplace transform of cosine function. So what is that Laplace transform of cosine function? So number 4, Laplace transform of cosine function ft. This is equal to always s square plus omega square. Ft is equal to cos of omega t. This is the cosine function. So there is a difference between this and this. Now next, parabolic function. Number 5, parabolic. If ft is equal to 0 for t is 0. Again, t square for t is greater than 0. Okay, so we want to express in Laplace transform, this is equal to 2 by s square. So you have to memorize this, all this is as final expression for if your function is this is the case. Okay. Similarly for ramp, ft is equal to 0 for t greater than less than equal to 0. Okay. T for t greater than 0 or ramp, Fs, Laplace transform is denoted by Fs. Fs means Laplace transform of Ft. So this is equal to 0 to infinity t e to the power minus st dt. So you can directly write 1 by s square for ramp function. Okay. Now let us consider, write down, let us consider circuit RL series circuit. Let us consider RL series circuit as shown in figure. Okay, R L P. Now we are going to apply Laplace transform. Now initial condition Ft is equal to 0 minus, this is equal to what? Tell me.
0.
0.
0.
0. Okay. So just close. IL 0 plus, this is equal to
0.
now. After closing, applying KCVL, write down V is equal to R IT plus L DIT dt. So same equation, yes or no?
Yes, ma'am.
Okay, already written up so many times this type of equation. So now apply Laplace transform. So what about this V? It's a what type of function? Laplace transform of V equal to what?
B by S.
V by S. Okay. Again now R. Laplace transform of IT is IS plus L. Laplace transform of this part S IS minus I 0 plus. So this is the case. DI. Okay. So V by S R IS plus LSIS minus 0, that is already there. We have written this 0, so we can write here 0. Now VLS IS, take this is common, R by L plus S. Okay. IS is equal to V by L S R by L plus S. Yes or no?
Yes, ma'am.
Is it okay? So after this, how to, now we are trying to find out IT. That is already Laplace transform. Now, after that, you have to take the inverse of Laplace. So, for that purpose, what to do? It's just 1 by S. This is the mathematics. R by L plus S into L by R. Okay. Now break this into two sections. How? Okay. Now A is equal to zero. We will get V by R. Again, B is equal to P by L S. Now you put R by L, you will get the expression minus P by R. So, IS is equal to US plus minus V by R, S plus R by L. Yes or no? Kwa বুঝি পারছাম নাই?
Yes, ma'am.
Okay, so you break this above term into two sections, A by this plus B by this. So how to find that A and B? By putting this condition, these two conditions, S is equal to 0 from here, and in this for S is equal to minus R by L, we'll get this. So these two expression, this is A and this is B. Now you can put there A equal to B equal to. Now, what is the inverse of this? Inverse of this is equal to what? Yes or no?
Yes, ma'am.
So e to the power what?
Ma'am, minus R by C.
R by L.
R by T.
R by L? Yes, T. So this is the final expression. So this type of expression already you have in this previous without using Laplace transform. Same expression you will get. But this is the way to solve the problem using Laplace transform. So in this case, no need to apply the initial condition. What is required? The classical method. In the classical method, you have to put t is equal to 0 plus. Yes or no? To get the initial condition. But in this case, in using the Laplace transform automatically, just you have to do this part. So this expression, you just compare with the previous expression, the same expression. So this can be written like this. This is already done. 0.9 R by L T. So this is the expression. What type of circuit? Force response RL circuit. Forced but RL circuit. So this is the Laplace transform application for transient analysis. So in this case, you have to remember these things, memorize these things. What is the unit step Laplace transform of step function, Laplace transform of cosine function, Laplace just you remember those things. Unit step would give 1 by s. If it is cos omega t, what will be the s by s square plus omega square? So that function, Laplace transform of that ft, you have to remember these things. Then only you can put it here. So, any question? No.
No, ma'am.
Is it okay? Okay.
Yes, ma'am.
So, one problem. Solve it. In the figure, Swiss is closed at position 1 at t is equal to 0. Swiss is closed at position 1 at t is equal to 0. Full stop. At t equal to 0.5 millisecond, the switch is moved to the position 2. At t is equal to 0.5 millisecond, switch is moved to the position 2. Okay. Find the expression for the current in both the conditions. Find the expression for the current in both the conditions. Sketch the transient also. Sketch the transient also. Okay. First, the given circuit, you draw the circuit to position 1, position 2. So 10 volt, 5 volt. So this is the given circuit. First it was connected, the position what?
1.
1.
1. Okay. So if it is connected with position 1, the force voltage 10 volt, okay, is applied for this circuit. What type of circuit is it? This is the circuit having R and L. Okay. Now, in this problem, the method is not mentioned. So you can use Laplace transform or you can go for the classical method. Let us solve this problem using classical method. Okay. First. So, first what to do? First step, switch is at position 1. Write down position 1. So try to find out the initial condition. 0 minus this is equal to what?
0.
0. Okay. Then I 0 plus this is also 0. Okay. Now you write down your KVL equation. 50 IT plus L di dt equal to what?
10.
10.
10. So this is my first equation. So after this, you can use the classical method or you can go for Laplace transform. Okay. Now try to solve this problem first using classical method. So for this purpose, what to do? di dt. Okay. This is equal to this is plus 50 0.5 it is equal to 20. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, correct. Now, di dt plus 100 it is equal to 20. Now, for this equation, what will particular integral and this solution? What is the solution of this equation? Therefore, what is the solution? Particular integral, what is that?
10 by 50 minus 0.5.
Particular integral is what? Expression v by r, right? Plus a. You don't know, you have to find out that constant. A e to the power minus t by t. So this is the common equation. If
Yes,
it is,
ma'am.
this is 0, this should be 0, that case. Okay. Since 20 is there, so v by r is the particular integral. So now in this case, to find out a, we have to put initial condition. Now, I0 plus, just switching, minus, same thing. Okay. This is equal to 0. Therefore, 0 is equal to v by r plus a. So, a is equal to minus v by r. Therefore, we have it is equal to v by r, okay, minus v by r e to the power minus what?
T
RT
L
by
by RT.
Then what is, you can put the value, numerical value. E to the power what?
Minus t by 100.
100t. Yes or no?
Yes, ma'am.
This is 100t. So what is v by r? 0.2, 1 minus e to the power minus 100t. So that is the final expression for it. So this is the transient expression for it when switch is connected with position 1. Now next part of the problem, what is that? At t is equal to 0.5 milliseconds, switch is moved to position 2. Okay. Now I 0.5 is equal to 0.2, 1 minus e to the power minus 100 0.5 into 10 to the power minus 3. So this is equal to what? Millisecond. So 10 to the power minus 3. So this is how much? Calculate. How much?
0.0097.
Okay, in terms of milliampere,
9.7.
9.75 milliampere. Okay. At this condition, at this situation, the switches move from 1 to 2. Okay. When, next part, when the switch is connected to position 2, so that case we have another equation plus L di dt, right? Equal to what?
5.
5. Okay? Now, when the switch is connected to position 2, that case I 0 plus, this is equal to what?
9.75 milliampere.
9.75 milliampere. So this is very important. Now the initial condition is not 0 because it was initially connected with position 1. Then it changes to position 2. So initial current that is equal to this. Now from this dit dt plus 100 it, this is equal to 10. Okay. So it is equal to yes or no.
Yes, ma'am.
Yes, ma'am.
Okay. Now we have another equation for another condition. So now putting the initial condition, now I plus is equal to 9.75 milliampere. Okay. So this is equal to then no, this is 5 by 50. Yes or no?
Ma'am, 5
Yes,
by
ma'am.
50.
Yes. So 1 by 10. So from here, this we can find A. A equal to minus 0.09. Okay. Now IT, therefore, IT is equal to 0.1 plus minus 0.09. This is A e to the power minus 100. Now what will be the T equal to what now?
T plus 0.5.
No. T minus T dash. T dash is different, no? Now, see. So tangent, draw the tangent. So first case you draw. What is that? 0.2. Okay. And next tangent. So this time is what? T dash. Zero. So this is the tangent response curve. So second curve, it starts from T dash. So বুজি পাইছা নাই কোৱা? T dash is equal to how much?
0.5 milliseconds.
Yes. So it will start. This is the starting time is 0 first for first one, but for the second one, so that is T dash. Now you try to solve this problem using Laplace. You should get the same answer. First, you write down this equation. Can you solve it right now? For at least first part,
Yes, ma'am.
try to solve this on the first part. Using Laplace, just R I S plus L S I S minus I L 0 plus this is equal to 10 by S. Itu pasan Naswa for the first part.
Yes, ma'am.
Okay.
Yes, ma'am.
So after simplification of this equation, you should get this is equal to 10 by LS S plus Now you break into two terms. A by S plus B by S plus BL. So all of you try to solve this problem yourself. Try yourself. Slightly complicated. So how much A and how much B? Find out A and B. A equal to
Ma'am, 20 by 100 plus S.
A equal to, yes. That means by putting the condition, this condition, how to put this condition? This is like this. S plus R by L, S is equal to 0. You should get V by R. Why not? Then again B, for B. B is equal to V by LS. Condition is, next condition. What is that? Minus R by L. So this is equal to minus V by R. Now you can write down the equation. So final equation, this is equal to IS V by R 1 by S minus 1 by S plus R by L. Paisan na ito soa. বই থাকিলে লাভ নাই হাত একদম কৰিব লাগিব এইটো নহব
Yes, ma'am, I sir.
Okay, now take the inverse of this. Inverse of Laplace transform. So we will get the answer same as this. So this way, same problem can be solved as proof that in the classical way or in the using the Laplace transform. Triporna, Triporna, ক'ত গ'ল জ্যোতিৰ্ময়
Yes, ma'am.
জ্যোতিৰ্ময় নাথ আৰু কলিতা দুজন আছা
Oh, ma'am.
আচ্ছা বুজি পাইছানে নাই নে এনেই বহি আছা কোৱাচোন একদম সঁচা কথা
পাইছো, ma'am.
তুমি যদি
ma'am, পাইছো।
নিজে যদি কৰি নোযোৱা পেইনটো লৈ পেলাই হ'বনে পাৰিবানে এক্সামত এইটো যে এবাৰ ওৱান টাইম হ'লেও নহ'ব তাৰমানে এইটো 3বাৰমান প্ৰেক্টিচ লাগিব এই ওৱান টাইম যে কপিখন কৰি পেলাই বাছ থৈ দিবা নহ'ব নোলাব এক্সামত গৈ হ'ব নেকি প্ৰেক্টিচ লাগিব এতিয়া নেক্সট পাৰ্টটো কৰা নেক্সট ইকুৱেশ্যন For the first part, have you got it? The answer, same answer, using the classical as well as Laplace.
Yes, ma'am.
Okay, now try to solve the second part, second equation after 5 milliseconds. When switch is moved from position 1 to position 2. Akshata,
Yes, ma'am.
ah,
Yes, ma'am.
what is your position? What is the understanding level? Is it okay for you?
Yes, ma'am. I'm doing.
Doing?
Yes, ma'am.
Okay, do it yourself. Try to do every deduction.
Yes, ma'am.
Okay.
Yes, ma'am.
This is only for your benefit, not for mine. Okay.
Yes, ma'am.
Otherwise, if the for offline exam, it will not be possible for you to solve the problem without practicing. Stay. For online, you can manage from your friends, but for offline, yes or no? Got it? Sharma, Som, CR? Have you got the second part? Can you solve it? Hitangshi?
Yes, ma'am.
কৰিছা নাই?
Yes, ma'am. কৰি আছো.
No, এনেই নকবা দেই, তোমাক নিজে honesty, be honest.
Ma'am, কৰি আছো.
তোমালোকৰ লুজ কৰিবা।
Okay, ma'am.
মোৰ একো নাই, মই কি আছে, পঢ়াই গুচি যাম ন। Who has got the answer? You should get the same answer, same expression, same curve by using two methods. Obhigyan Borua?
Yes, ma'am. Almost হৈছে, ma'am.
Almost হৈছে?
Yes,
সঁচাই
ma'am.
কৈছা নে?
Yes, ma'am. Yes, ma'am.
মিছাকৈ কি লাভ হ'ব কোৱা?
Done, ma'am.
Done. We got the same answer.
Yes, ma'am.
And again তুমি কাৰ্ভ দুডাল ড্ৰ কৰিবা। তাত ড্ৰ কৰিব
Okay,
কৈছে,
ma'am.
transient response. Problemot কৈছে, okay. If in the problem that its method is not mentioned, you can solve the problem any method. That is up to you. Using Laplace or classical. কোনটো ভাল হ'ব তুমি ভাবা? What is your opinion? অভিজ্ঞান?
Ma'am, ma'am, Laplace-টোত অলপ মানে complicated পাইছো, so মানে like basic method টো ma'am অলপ বেছি
Classical
suitable
method
হ'ব।
too, that will be better.
Yes,
No,
ma'am.
no, a Laplace Laplace, you try to solve problem in Laplace, it will be again convenient for you because there is no need to put the initial condition for Laplace.
Okay, ma'am.
That is the main. But in normal classical method, you have to put the initial condition to find out the constant. But in the Laplace, it automatically comes. Because in Laplace are automatic. Laplace no need to go for the putting the initial condition. That is up to you. G Cora. But if it is mentioned in the problem, you should go for it. So try to solve the problem, same problem. You take one problem, try to solve that problem using Laplace as well as using classical. Okay. So for today, okay. And for tomorrow morning, I will not be in a position to take your class because I had left Viva in the college. So I will take your class in the Friday, second period. Okay. So you are free in tomorrow morning. Yes or no?
Okay,
Yes,
ma'am.
ma'am.
So tomorrow morning, there will be no class. So next class Thursday morning and Friday, second period. Okay. For my part. Okay, I wind up here. Bye.
Thank you.
Thank you, ma'am.
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 Yes, ma'am.